We were really excited when he contacted us to potentially do a walk and to do this talk tonight, because his book, Fascinating Fungi of New England, is a staple in our teaching library here at the Harris Center. For those of you who don't know him, he's a mycologist and he's written a number of different books, including Fascinating Fungi of New England, At the End of the World, Last Places. And he's done mushroom work, mycological work in places as diverse as Greenland, Honduras, Iceland, Panama, the Arctic, and Cambridge, Massachusetts, where he's documented 321 different species, which is pretty amazing. Tonight, he'll be sharing with us some stories from his latest book, Fungipedia, which you can get at our wonderful local bookstore, Toadstool Books. They are also sponsoring tonight's talk. And they're in Keene and Peterborough. They've got copies of at least 2 of Lawrence's books on hand, including the one he's going to share with us tonight. And we just can't say enough great things about Toadstool, because they're just a wonderful local business, and they ship if you're not local. So with that, oh, one last thing that Lawrence told me yesterday that's pretty exciting is that he has actually had a mushroom named after him, which is a pretty impressive accomplishment for anyone. So with that, I'm going to turn it over to him, and welcome and thank you.
Thank you, Brett. I have to offer a little correction. It's now 347 species, and it isn't all of Cambridge. It's just one area called Fresh Pond, where I have documented 347 different species of fungi. Now, I want you to stay to the end, because at the very end, there's a piece of music that has quite a bit to do with mushrooms. And I'm going to play it. And if you can either guess the composer or come close, you will get a reward. I'm not going to say what the reward is. I can only tell you as a clue that it is pertains to fungi, and it isn't actual specimens, but something that might have print in it. Okay, now look at this picture. I would like to welcome you to my favorite kingdom in all the world, Kingdom Fungi. It's a kingdom of its own, as plants and animals are also kingdoms of their own. And here I am trying to identify mushrooms in Iceland. And as you can see, I don't know if this cursor, can you see with the cursor?
Yep, we can see.
Okay, yes. Well, this is very important. This is a bottle of what's called Brennivín. It's an aquavit, and you cannot come up with a new fungal species without help from a libation. Take it from me. Now, next, you know what this is? It's a toadstool, not to be confused with Toadstool Bookstore, which is named after it. And this represents, and again, don't think of the bookstore in this regard, an age-old phobia about mushrooms. Toadstool, we don't know quite what the origin of it. I talk about this in the book, but it could be a corruption of Tod, death, Stuhl, chair, which is German, that somehow made it into English as toadstool. It also may have to do with the fact that it was long believed that toads imparted their venom to anything they sat on, including mushrooms. And what this is called is mycophobia. You may have heard of arachnophobia, and it's a phobic reaction to spiders. This is mycophobia, and I'm going to recite a sort of iconic example of it, a poem by someone you may have heard of, named Emily Dickinson. Had nature any outcast face? Could she a son condemn? Had nature an Iscariot, that's Judas. That mushroom, it is him. So Emily, you could say, was mycophobic. So what I am going to do in this presentation, and what I try to do in my book, Fungipedia, is remove the toad from the toadstool, as you can see, no longer there. It's removed. So you can see fungi are, as they really are, without a blanket of human beliefs and phobic reactions. I'm going to mention too that had I given this presentation 20 years ago, I might not have in fact given it. There's recently been an incredible spike in interest in fungi, and fewer people have a phobic reaction. And instead, like this woman, they show an affection rather than a fear and an anguish toward mushrooms. One of the things that is true, this is an artist's conch that has a etching on it that a young woman made during one of my walks when I started talking about the underside of artist conchs. And I thought it was appropriate for this talk. Miles does too, I can tell. And it's gone so far, the spike I mentioned has gone so far as to proclaim that fungi can save the world. Now, there was a movie called Fantastic Fungi, which you might have heard of. There are various individuals giving TED Talks making that proclamation. My own feeling is, however, that they can save the world just by being themselves, by being left alone, by not being utilized by us overly utilizing human beings for any uses that they can be put to, pale beside what they're actually doing in the natural world. More on this later. I'm now going to tell you how I got interested in fungi. And by the way, I'm going to use the word fungi or fungus interchangeably with mushroom. But if you want to be formal, a mushroom is a mushroom-shaped fungus, and a fungus is any fungal entity, and it would include that mushroom-shaped fungus. So I got interested originally. I did ethnographic work. That's me on the far right. Ethnographic work in the Arctic with native people, as the people who helped set this event up would be willing to tell you. I'm a somewhat backward individual. And as a result, I tend to have hung out with people who were considered backward, but I never considered them backward. I considered them traditional and informative, and they had a very close relationship to the earth. Now, these are two Inuit who are indeed still nomadic, or they were when this was taken. I think this is 1991. They're living in a caribou hide tent. And from people like this, I collected lots of traditional lore and wrote about it. Stories, customs, superstitions, odd medicines, and such like. And every once in a while, I would happen upon a person who would provide me with fungal lore. Now, look here in this lower left-hand corner. This is a polypore, bracket fungus, like the one that you saw several slides ago being worshipped. This woman is a 104-year-old Wiccan woman from the Yukon. And this is what's known as chu. It's a bracket fungus that is cooked, turned into dust. It has a tobacco leaf wrapped around it and then put into one's mouth. And the alkaloid and the alkaline combined give a nicotine high to the chewer. It's not an overwhelming high, but it is a high. And this has been going on with native people in Alaska and the Yukon ever since whalers started trading tobacco with the locals. And, you know, it's some of the Alaska Native Health organizations damn this because they say it can cause health problems. But I asked this woman, 104, how long have you been chewing this fungus? And she looked thoughtful for a moment and then said, oh, about 90 years. Now, here is an example of a phobia. This is East Greenland. And mushrooms are called Kivigtok sopa there. A Kivigtok is a supernatural demonic form that can fly by twiddling its fingers and legs, and it can fly into a village, make off with an individual, and then eat that individual. So one has to be on the alert for these. And Kivigtok sopa refers to Kivigtok soap. In a lot of cold places, and as you will find in New England as the season progresses, mushrooms have a slime on them that serves as an antifreeze, i.e. when the temperature dips low, that slime helps them not to freeze. So what this indicates is no, we will never want to eat a mushroom that a Kivigtok uses to bathe with, like this thing. Now, here is a PG-13 image, or it will, I cannot help but talk about it because we owe ourselves to what's depicted in this image. Raven, who is in the bow of this canoe, created the world, as we all know. That's capital R. And he created plants, animals, etc. But he didn't, and men, but he didn't know what to do next. So he contacted his very good friend, Fungus Man, who's sitting in the stern of this canoe. Now, Fungus Man is the personification of another bracket fungus, Lyriciphomes officinalis, and which is pretty commonly used in medicinals nowadays and was in the old days. It used to be traded all the way from Alaska and the Yukon down to South America to help relieve the pain of scorpion bites. And it also was called the quinine conch because it was used as a kind of quinine. Anyway, Raven asked his friend, Fungus Man, seen here, what do I do next? I've treated men, but now what? I mean, they're just staying there. There are no new human bodies. So Fungus Man said, I will solve this problem for you. Hop in my canoe. They hopped into the canoe, and Raven and Fungus Man took Raven to the small island where female genitalia lived. And this was an astonishing thing for Raven. Fungus Man said, collect them and bring them back. They were skittering all over the rocks. So lots of buckets. He went back, and then Fungus Man told Raven, plaster them on half of the men you see. And he did. And suddenly the other half looked with a mixture of astonishment and delight at the half on which had been plastered the genitalia. And as the old man who told me this story, we wouldn't be here if it wasn't for Fungus Man. And I suppose if I wanted to be maybe amusing, you wouldn't be here listening to my presentation if it weren't for Fungus Man. I described this in the book, by the way. So all of this got me interested in fungi, but my real interest was ignited by this elderly gentleman who's about 93 in this photo, Sam Ristich, who was known as the northeastern guru. And what was good about him, he was an entomologist as well as a mycologist. He knew all about nature, so he could see the forest for the trees. So he didn't spend his time just identifying mushrooms the way that some so-called experts might be doing today. You know, he would talk about what they were doing in nature. He would talk about, on one of the mushroom walks, he says, can anyone guess what the most interesting find was? And no people guessed. He said, none of that was correct. It was a very unusual millipede. So he was sort of my guru, and he was commonly would say hallelujah when he found something interesting. And I once visited him, and in his refrigerator, this exacerbated his wife. There was a giant collection of animal dung on which he was culturing mushrooms, far more animal dung, in fact, than actual food. Whoops, okay. Now, here I am in the Arctic looking for mushrooms, getting down and dirty with them. It's very important to get down and dirty with something you're studying. And dirt is, as parents are slowly starting to realize, has wonderful bacteria-fighting bacteria itself, as well as other organisms. And as a kid, my father once said to me when I was about 6 or 7, you know, you're the dirtiest boy in all the world. And when I heard these words, my chest swelled with pride. Anyway, here I am there, and you know, you might be thinking, fungi in the Arctic? What's going on? And of course there are fungi in the Arctic. There are lots of them, and they're essential, but that's the subject for another presentation. I'm now going to read you a poem from a book just released called Goodbye Ice, Arctic Poems. And a lexinum is a bolete type mushroom. This is a short poem, so no need to look perplexed. And this is from Baker Lake in the Canadian Arctic. All praise the mighty lexinum, a scaber-stalked mushroom that readily spreads its spores in a habitat so windblown and likewise so frigid that if a redwood, seemingly mighty itself, somehow found itself here, it might bawl these words: California, where art thou? Anyway, yes, there are a lot of, not in this photo, but you can Google lexinum, L-E-C-C-I-N-U-M, and you will see numerous images of it. You have it, by the way, in New Hampshire too. Now, edibility for me is the least interesting aspect of any fungus, unless the diner is another critter, like this millipede eating this former rusula. Yum, wouldn't you say? Or this is what's called the lobster mushroom, and it's a hypomyces species dining on a rusula or lactarius, thus creating the lobster mushroom, which is considered a very, very high-end edible, as you probably know. Now, here you have, you know, without going into too much detail, every fungus except for yeast owes this existence to a mycelium. You cannot see a mycelium, but when it's only one cell wide, and we can see each other because we're human beings are a lot more than one cell. Anyway, this is mycelium that has bunched itself together to form rhizomorphs, and there might be 10, 20, or 30 strands here. And what that happens when there's some type of environmental stress, like, for instance, a drought. And this has been, given the fact that this has been a drought year and a terrible one from a fungal point of view, you see, if you lift up logs or look on the ground, far more rhizomorphs than you would have ever seen before. And what they're doing here is they're storing nutrients. The mycelium is aware these times are tough. And just as people at the very beginning of COVID started going to stores and stocking up on food, what my rhizomorph is doing is stocking up on nutrients that it feels will be helpful in a difficult time, allowing it, in fact, to survive. I suspect you follow me. Now, there's one other thing, too. They will form rhizomorphs like this when they've eaten all, the mycelium has eaten all the nutrients in its substrate, that is, in wood, if all the digestible things have been digested. And in any given log, by the way, there are probably 200 or 300 different species of fungal mycelia, all competing for that food. So it's not just one who's turning a 9-foot log into soil, it's dozens. Anyway, if it's all been digested, what they do in this rhizomorph is they head out into new territory looking for a new food source. And, in certain cases this year, when you see these under logs, it's probably because the log, it is all dried out, no rain, and the mycelium is forming these rhizomorphs to go somewhere else where there might be some edible food. And given the situation, the log it finally will find will probably be just as dry as the one that it left, unfortunately. Now, I don't want to go into too much detail here, but I don't know how many of you know the word mycorrhizal. This is a symbiotic relationship between mycelia and a plant or tree. And you can just look at this in a vague sort of way and listen to me more than look at this. This is a very important relationship. And it does this, the mushroom, which has a mycelium connected with the plant or tree, needs carbs. It can't photosynthesize like us. And in fact, and I say this in the book too, fungi and us are related, surprisingly close on a phylogenetic tree. Anyway, so it needs to get carbs, and it gives the tree or plant phosphorus, potassium, etc., in return to these. So what's happening is the photosynthesizing plant or tree is drawing, it's a very noxious molecule, villainous, you could say, CO2 out of the atmosphere and routing it down to its roots where it becomes a carbon and is connected underground with the mycelium. And this is why reforestation and planting in this time of global warming, climate change is so very important, because the trees and the fungi, they're partners. You could say the fungi are helping us fight climate change. Now, here's some wood, and this is what's called cubical rot. Not surprising. It's sometimes called brown rot. And what's going on here, it's about 80% of the time you see this, and you know, go through the woods, and if you don't see fungi, you will see this. The mycelium is eating the cellulose, which is what forms the cell walls in wood, leaving the lignin. And the result are these brownish blocks. 80% of the time it's conifers. Maybe 79 or 81%. I'm not exactly sure. But what's interesting is in coniferous forests, brown rot residues enrich the soils enormously and make these soils susceptible or highly favorable for seed germination. If it weren't, in other words, for the fungi that are rotting the dead wood, it could very well be that those soils would end up being very poor and there would be a vastly smaller proportion of plants. Now, I'm sure you recognize, most people know what this is, even if they don't know much about fungi. This is what's called a turkey tail. And look at them here. It's so called because it resembles the flared tail of a tom turkey. And it's very interesting because this is a white rotter. It is eating away at the lignin in the wood, and the lignin is what makes the wood rigid. So the result will be loose and cottony. And it's very interesting. Go to any log you see with this kind of fungus on it. Try to find a place where it's open and grab the wood, and it often will break into pieces in your hand because of what's called white rot. And there is no other organism on this planet, and presumably any other, that can engage in white rot except white rot fungi. Now, I also want to point out something else here. You've got a lot of turkey tails here. That's not at all surprising. You never find individual turkey tails. I'm going to tell you why. Because the turkey tail mycelium releases in the log pheromones that say to all the other fungal mycelia, this is my food, stay away. And they're potent. And those other mycelia do stay away, which then allows the turkey tail mycelium to take out the innards of the of the log, and then they produce all these fruiting bodies. In order to produce fruiting bodies like this, you need a lot of food, and they're getting it because they told every other fungus to go home. I'm sure that makes some sense. And as I said, fungi and us are very closely related, and we are very competitive. So are fungi. Okay, let's see my next in line. Now, I'm sure you recognize this non-fungus, this woodpecker. And I'm sure you're wondering, why the bloody hell do I put a woodpecker in a talk on fungi? Because obviously it's in a different kingdom. Well, there's a very good reason for this. I've meant the previous fungi that I've mentioned, the turkey tails, they're what's called saprophytes. They will recycle dead and dying wood. They're also fungal parasites that will attack relatively healthy wood. And these fungi, if they could talk, would say, life comes from dying. And, you know, they often attack the older trees in the forest, thus opening the canopy for younger trees and plants. But also they'll form brackets in the wood. They're eating away at the inside of the wood here. And what is happening is that cavity nesting birds look for the bracket fungi and know that the wood is eminently nestable in. That is, it's softer. They will not have to hack away at it in some wholly arduous fashion to make a nest. It's already loose, and it's especially so with what I just mentioned to you, the white rotters who turn the wood and make it loose and cottony. So this woodpecker just has to use a lot less work, and it's doubtless found somewhere on this stump a bracket fungus sticking out. They are indeed looking for such things because those bracket fungi tell them where a good nesting spot is. Isn't that interesting? Now, fungi come in a remarkable variety of sizes and shapes and forms and colors that they would make any artist green with envy. And here is a cup fungus. By the way, this is, I don't want to go into too much detail. It's called an ascomycetes, and they launch their spores up, whereas the mushroom-type mushrooms drop their spores. And you all know what a morel is. It's in the same family as certain cup fungi. Think of it as a bunch of cups that have been soldered together and raised upwards in an upright position. And if you sort of can imagine these cups soldered together, I mean, soldered is not something that happens in kingdom fungi. It's only human beings engage in that activity. But if you imagine these soldered, and it's out of these holes the spores come. So now here is what's called a tooth fungus. And you can touch them, they won't bite you. This happens to be a species that I found in 2009 in Ipswich, Massachusetts, that had never been documented in the New World before. And I didn't identify it. I couldn't. I didn't know what the hell it was. And I sent it to a friend who didn't know, and he sent it to a friend who sent it to a friend who happened to be a Japanese woman and who knew Asian species. This is an Asian species. And I found the first New World specimen. It's an Asian subtropical species, and I found that specimen in December when the temperature was below freezing. Now, consider that. We know so little about fungi. I mean, what the hell was going on? Here was a subtropical species that was doing just fine in freezing temperatures in New England. And, the world of, I recommend to anybody here who's looking for a subject to study when they grow up, when they grow up, mycology, the study of fungi. There are so many questions, and this is only one of them. And I'm going to get to another one of them soon. But this is not it. Look at this. This is what's called radicating. That means the root or the stem goes deep, deep, deep into the ground. I think this was about a 2-foot long stem. It's growing on buried woody debris. And it reaches down to the soil to find it. And it has evolved not to grow on tops of logs, which seemingly would be easy, but to reach down and find that buried wood, which is its chosen substrate. And who knows? It could have been initially at some point in the distant past, growing on the surface, and then the competitive fungi were saying to its mycelium, get the blazes out of here. This is our wood. And it evolved slowly over time to grow on buried wood. Now here is a large bracket fungus right here on the right, not here. And as I said, they can either be saprophytes or the parasites, but there's a very gray area in terms of what they're doing. I mean, if this tree is healthy except for one place, a fungus could start growing there and it could weaken the rest of it, which could then attract other fungi. And it could be a small weakened area in a healthy tree. So is it a parasite or is it a saprophyte? My own feeling is that, anything with a weakened area, be it a human or a tree, is immunocompromised and an attractant to things like this. This is something we found around here. I'm sure you've seen it even on your property. It's a polypore that is erroneously called the red-belted polypore. This is a white belt, as you could see, and the Latin name is Fomitopsis pinicola, which is also erroneous. Pinicola means pine, and 30% of the time you find it on deciduous trees. Also, it is a perennial, meaning it can live almost as long as it finds nutrients in its host. There are also annuals. I'm not going to show you one, but with climate change, some of those annuals are becoming perennial. The reason that an annual is that it can't deal with the cold weather of winter. With that weather getting less cold, it is finding a longer growing season. So now, I mentioned mycology is a mysterious science. Here is a purple. This is not Photoshop, by the way. It's a purple, what's called a purple court. And its color, why purple? Why that strong color? It could well be that that color aids in absorbing heat, but we don't know. And mycology is a young science. 1837, the word was first coined. And there's all sorts of room to study what's going on here. Why is it purple and not green? One of the theories is that the mycelium is putting all sorts of chemicals into the fruiting body, which metastasize. But, you know, this is all very vague and needs to be pursued. Again, you're looking for a career, you have no further to go. Now, here's the point of everything. Spores. Every mushroom, every fungus, again, except for yeast, is an evolutionary proclamation that says, with this shape, this is the best way for me to produce and spread spores. Now, spores are very small. These are not inches, they're microns. And that's 1 micron. Sorry, this is 1 micron. That's 2 microns, that's 3. They would be invisible to the naked eye. Except sometimes, paradoxically, they're extremely visible. That's because a lot of them, like for instance, this polypore, will produce millions of trillions of spores during, let's say, a 10-year lifetime. Almost all of them are going to end up in the wrong place. Maybe on this person, maybe in a parking lot. That's why they produce so many. And you could say it's parallel to why human males produce so many sperm. But yes, the common, shall we say this way, you know the supermarket button mushroom. Well, the wild version, which is called the meadow mushroom, believe it or not, when it's sporulating, produces how many, this could also be the question with the prize, how many spores per second? 30,000 spores per second. I dare say that's rather a lot. Now, here's a species called Phallus imputicus. The name Phallus indicates, the genus name indicates its shape. And this is interesting because you can see this is slimy. And that releases a smell that's not unlike rotten carrion. It's what's called a stinkhorn. And I have to tell you that I am a great admirer of stinkhorns. I'm sure you've seen them around, especially in garden mulch. You've seen them around, and I've seen them around, and I actually rather like the smell. I am, in fact, and I say this with a certain degree of modesty, the president emeritus of the ASS, the American Stinkhorn Society. And in its prime, believe it or not, we had not 5, but 7 members. No one wanted to do the work, though. The logistical work of being a president was beyond me. I wanted to be outside rather than inside. Anyway, this creates a smell that attracts the flies to come and spread its spores. That's the whole point. Spread the spores. Do whatever you can to spread the spores. Now, this one you may know about. It's called an ophiocordyceps, and it'll attack insects, in this case, ants. And its mycelium gets inside the ant. And probably a better way of putting the slide up was making it vertical, because it makes the ant climb. And it climbs to a certain height, which is the height that the fungus wants to be at in order to drop its spores. And then the mycelium takes over the brain in a way that causes the ant to latch on to whatever it's on, be it a branch, a limb, a stem, or something. And it not only does that, but it does it so that this will be growing and dropping spores over a place where there's an entourage of ants on the ground. It knows where the ants are, and it wants to create more of itself, and that's the way it does it. And you could say, well, I think it was Dr. Watson who said, in response to something Sherlock Holmes did, very cunning. Now, here is a species that I have yet to identify. I found this in the Yukon Territory last summer. And the people I were with, men and women, all said, how cute. And such species, in fact, inspire our oxytocin and make us want to cuddle them. And as you might know, oxytocin is known as the cuddle hormone. And so I've said cunning, and I've also said cuddle with respect to fungi. Now, these are, it would appear that I'm engaging in anthropomorphism. And maybe I am. And maybe I am at the same time I'm being scientific. I would say that it's difficult, if one is a human, not to be anthropomorphic. And even scientists now, which I sometimes am, a scientist, are increasingly being anthropomorphic in their papers. And here are just 2 titles of papers that indicate that. One is called Dating in the Dark: How Roots Respond to Fungal Signals. And another is called Indifferent, Affectionate, or Deceitful Lifestyles of Fungi. And I should say, with respect to deceitful, that some mycelium that are going to connect, presumably with the roots of a plant or tree, mycorrhizally, will release a signal, but they will not provide any nutrients. Many of them will get nutrients in return for offering nothing, because they've, shall we say, confused the roots into thinking that those roots are going to get something in return. But sometimes the roots know it, and they cut off all connection with those mycelia. I'm not making that up, by the way. Now, here's something, this is now a fad. You know what this is. You don't get it at a UPS store, however. It's called Chaga, C-H-A-G-A, and it is now the medicinal fungus of choice. I mentioned the spike in medicinal fungi. This is the most celebrated one. And if you go online, you might end up getting 4 billion hits. And you'll also get different types of what it will cure you of, everything from gout to epilepsy to cancer to emphysema, maybe even angst. So it is the universal curative. And rather than go into my own, and I do in the book, Fungipedia, mention my own, I would say, what would we call it? Not dismissal so much as dubious attitude towards medicinal fungi. There's not a lot of scientific work. I think an interesting question is why? Why at this point in human history has this become so popular? And one reason is I think a lot of people realize that they've turned their backs on nature and now they are reaching out. Maybe not in the best possible way, but reaching out. Another reason is that they are eager to get away from big pharma and its rapacious designs. And this Chaga will help them do that. Now, far more important to me, and this is hard to tell, the Chaga, this is a sclerotium. It's not really producing spores. It's something that the mycelium has produced to encapsulate all the, it's on birch, Chaga is on birch, and the birch tree is releasing all these inner chemicals that are trying to fight off the mycelium, which is happily dining on it. And the mycelium is putting these chemicals into, like betulinic acid, for instance, into this sclerotium. But what this is the fruiting body, and you can't really see much because it's a moth-eaten rag. It's under the bark. It attracts insects to come and spread its spores, releases a smell, and by the time the bark is broken, it's pretty much gone. And that's why it's seldom documented. She's known as Lady Chaga. She's found more specimens of the fruiting body than anyone else I know. So here is over collecting. By the way, how are we doing with time? Okay.
Yeah, we have about 5 more minutes.
I've got 5 more minutes, 7 more minutes will be fine. Okay, this is over.
I'd love to have a couple minutes for the questions that have come in too.
Okay, very good. This is over collecting. It happens all the time on, regional mushroom forays and by people collecting edibles. And it's, from my point of view, a very bad thing, because doing that reduces the genetic diversity of numerous fungal species. They're not producing spores, and it's, I think, bad taste. People say, "Oh, I'm not damaging the mycelium." You are damaging the mycelium. The mycelium is putting an incredible amount of its biomass into these mushrooms here. And I'll briefly mention this. I found this. This was declared extinct in 1909. I found it in 2006 in New Hampshire, believe it or not, on Atlantic white cedar. Atlantic white cedars were being cut down, used in shipbuilding and houses and so on. And this only grows on old Atlantic white cedars. It was declared extinct because there were no more old Atlantic white cedars. So it wasn't over-collected, but its substrate was being destroyed. Now some of them are allowed to grow, and presumably this will return to being just a few specimens. So what I recommend is, instead of over-collecting, what you do is you gaze in awe and astonishment that these two people are at this particular fungal entity. Or you take photos, as this gentleman is doing, of this particular fungal entity. Or this is Beatrice Potter. She illustrated mushrooms, and she was an excellent illustrator, but she wasn't allowed to deliver scientific papers, and she became simply a kid's book illustrator. But she did excellent illustrations. So did this woman, Actually, this isn't a woman. This is a bolete species. And a woman named Mary Banning in Maryland was a wonderful illustrator of fungi in 19th century, but she was also a woman. So she was banned from mycological circles. And individuals who saw her in the woods collecting mushrooms in Maryland would say, "Poor thing's gone clean mad." She wrote a book called The Fungi of Maryland that still has not been published, although she wrote it in the 1880s. Or finally, you could, not finally, but you could do what I did, which is write about fungi in this book, Fungipedia, which I heartily recommend and which contains most of the information that I've delivered in this presentation. Now, finally, okay, well, here, by the way, I hope I've shown that mushrooms are not toadstools, but they can be salamander stools, as you can see in this photo. Now, finally, a piece of music we played. I don't know if anyone has any guesses or thoughts about it. This will segue into our Q&A section. And this is the composer. Any thoughts?
There's one guess of John Cage.
No, not close, but an interesting guess because John Cage was a mycologist.
Huh. There's also a guess of Handel.
Handel?
Mm-hmm.
No.
Charles Ives?
No. I think maybe we should, what do you think? Call a halt to it and I'll tell you.
Any last guesses? 3 seconds. Doesn't look like it.
It's not quite 6:30. All right, I'll tell you. I won't read. There's an entry on this gentleman in my book. His name is Vaclav Halleck. He was a Czech mycologist and composer who would go into the woods, listen to mushrooms singing in the woods, and he would write in his notebook down their songs. And different ones had different songs. He wrote 1,500 pieces of music, all of which were mushroom songs. And what you heard was the very beginning of what is called his myco-symphony, mushroom symphony, because once he went into the woods and all the mushrooms were singing at once. And he turned that into a symphony. As I said at the beginning, at the very end of the entry, with respect to his eccentricity, I'm not sure what one would call it. Anyway, might Halleck's compositions be an example of synesthesia? Perhaps an example of Czech humor, possibly a form of sophisticated madness. Halleck was also a mycologist who co-authored scientific papers, so maybe he was simply merging his two passions in a somewhat unconventional way. Okay, thanks very much.
Thank you so much. You can't probably see us all, but we're all clapping.
I now can only see 3 people, one of whom is me, and I'm not clapping.
So it is 6:30. So if anyone needs to hop off, we understand. But I will, maybe if we could just take maybe 3 minutes to ask some of the questions that came in during the presentation. I'll ask a few of them, and
Okay.
hopefully, we won't keep people much longer. But there was a couple of questions about the reindeer's relationship to mushrooms, and if that's something that you could speak to.
I know quite a bit about it. I talk about it in the book. First of all, the Santa Claus has a very powerful relationship to mushrooms, and this will go on and on. Santa Claus is, in fact, a mushroom, but you'll have to buy Fungipedia to find out. Reindeer tend, especially male reindeer in rutting season, And I could go back, if you remember the mushroom on which the toad was sitting, and it's also on the cover of my book, Amanita muscaria. This is a mushroom that especially male reindeer love to eat during rutting season. And one reason they do is it makes them somewhat high. It gives them an elevated feeling that they are, as it happens, flying. So if you want to think back to Santa Claus and how he got around, the story is, shall we say, impregnated with lots of lore about the behavior of reindeer and how humans feel, and they tend to route that feeling of flying to the reindeer. And this may indeed have its why Santa Claus is being pulled around by flying reindeer. You'll have to read the book to find out more, though. Any other questions?
Oh, there were so many, but I'm trying to find one. So one question was, like, how do the turkey tail, you talked about the pheromones. How do other mushrooms or fungi perceive the pheromones that are being released by the turkey tail?
That's a very good question, and it would take about an hour for me to answer it. But they are all releasing in their own way pheromones, and some are more powerful than others. And what's happening is the mycelia is releasing this, and I'm going to have to be slightly anthropogenic, but the other mycelia are detecting it, and they realize, I'm trying to think of an equivalent human analogy. If there's a big fat bully in the room and you want to have a gentle conversation with somebody, you might want to leave the room. So this is a bullying mycelium that's releasing pheromones that the other mycelia detect. It wouldn't be releasing them, but for the fact that the other mycelia could detect them. And they often, what happens too, is with respect to certain species, they're very genteel. And they grow only on the surface because they know that their mycelium can't compete in the inner part of the log with mycelia that are there. So, you know, little cup fungi and little tiny unidentifiable LBMs, their mycelia don't go deep. They're not aggressive the way some of the others, like the turkey tail, is. I hope that comes close.
Thank you. That's fascinating. So we're about 5 minutes over, so I think maybe we'll call it here, but I will encourage everyone to visit Toadstool and buy Fungipedia and really dig deeper into some of these stories. And also a reminder that this will be posted to our YouTube if anyone wants to share this with someone who couldn't make it tonight. So thank you all for coming, and thank you especially, Lawrence, for sharing your humor and knowledge with us. We really
my pleasure.